Hey folks, Scott Walters with the Bulletproof Garage. Today we're going to be measuring the cylinder bore and the taper on our 7.3 IDI diesel engine block. This is a fairly simple task and something you can do at home with relatively inexpensive tools. So let's get started. Okay, one thing we need to understand before we move any further is how your cylinder wears and why, all right? Your cylinder is going to wear in an oblong manner. That's why checking bore, taper, and out of round is so important, all right? Because an oblong cylinder is not going to seal as well as a perfectly round cylinder. Now, why does your cylinder wear in an oblong manner? It's because of the forces generally that are exerted on the piston, on the power stroke, and on the compression stroke. So as your connecting rod comes up, all right, and down in the cylinder, all right, it doesn't stay straight up and down, all right? Obviously, it's moving as the crankshaft revolves. And when your engine hits the power stroke and the compression stroke, that's going to put some forces on the side of the piston, all right? And I'm talking about the side of the piston that is perpendicular to the center line of the crankshaft. So here and here. There's a name for these parts of the cylinder wall. That's called the thrust, all right? So it's here and here, and it is perpendicular to the crankshaft center line, all right? Again, that's caused by the forces in the compression stroke and the power stroke. That's going to cause a little bit of a side load on the piston, and as a result, some more wear on the cylinder, all right? So this is your thrust, and this is your non-thrust, all right? Your non-thrust really doesn't see the same loads that the thrust does. And so when you measure your cylinders, you're generally going to get a wider measurement here than you are here, all right? And that's what causes your cylinder to be out of round, all right? So let's say we're measuring this cylinder, all right, about an inch down, all right, just below, slightly below where the ridge is going to be right here, all right, slightly below where that compression ring stops, all right? So that's the area that is worn by the compression ring on your piston. So this measurement is going to be greater than that measurement because of the way the piston wears the cylinder, okay? Or really the rings wear the cylinder. And there's a spec for that. This particular engine has to be within 2 thousandths. All right, if it is greater than 2 thousandths out of round, that means you need to go ahead and bore the cylinder out to the next size. And for this engine, that's 20 thousandths. And that's a lot of expense. All right, boring and honing and buying a new set of pistons is quite expensive. All right, so that's why it's really important to check to see if you're within spec and not just go ahead and tell the machine shop to bore it out. Because all you may need to do, all right, is install new rings on your existing pistons. Save a lot of money, all right? Obviously, you need to hone your cylinders, and that you can do that at home as well. Now, so that is out of round. That is the difference between the thrust measurement and the non-thrust measurement. Again, thrust is going to be greater, non-thrust is going to be generally less than thrust, and we've got to make sure we're within spec, all right? And that's measured at the same distance down the cylinder, all right? So that's comparison of those two measurements. Now, what about taper, all right? Taper is measured on the thrust side, all right? So that's a single measurement taken at different places down the cylinder. So to measure taper, I'm going to measure once at the top, again at the middle, and again down near the bottom of the cylinder. All three measurements are going to be within that area where your piston rings are wearing the cylinder, all right? So I'm going to stay in the shiny area of the cylinder. Now, why does your cylinder have taper? It's very simple. Think about again what we talked about. You've got the compression stroke and the power stroke, right? Your piston moving up and down in the cylinder. On that compression stroke and the power stroke, remember, you're going to have some heat here at the top of the cylinder. And as you move further down the cylinder, you're going to have less heat, all right? The heat obviously caused by combustion, all right? Now, what about other forces? Think about what's going on inside the cylinder. You're getting oil inside your cylinder, all right? And it's the further you go up your cylinder, the less oil you're going to have on those cylinder walls, okay? And that is going to cause additional wear, all right? So your cylinder is going to see some taper over time because of heat and less oil near the top, all right? And this engine has a spec as well for taper, and the spec is 3 thousandths, all right? So if you're within that spec for out of round and for taper, you can just, again, reuse your existing pistons if they're in good shape, change out your rings, break the glaze on the wall, and save yourself a bunch of money. That's why it's important to be able to do these measurements and to understand why you're doing them. All right, first up, we're going to use our digital calipers. These are made by Fowler. Good brand name, good quality, reasonable price. All right, and you want to go ahead and use this side of your caliper since you're measuring the inside diameter of something. You don't want to use this side right here, all right, when you can use this side. All right, there you go. And here we go. And we've got 4.103, and that is our first problem, all right? So, I know this block is a standard bore, which is 4.110. So why am I getting 4.103? Well, I'll tell you why. That is carbon, all right? So with these calipers, I'm only able to measure right above where the compression ring stops in its travel, all right? So that means there's some carbon that's built up over time right up here in the top. So that's going to throw your measurement off a little bit, okay? So that is really the limitation of using some calipers like this. Okay, so how do we get around that issue, right? Because our caliper doesn't reach far enough down into the bore to get an accurate measurement past where the you're going to have that little bit of a ridge in your cylinder. Okay, so what I have here is an inexpensive tool. It's called a snap gauge, all right, also called a telescoping gauge. These legs are spring loaded. However, you can lock them down, all right? And there's no mechanism for measurement on here, all right? So what you have to do is you have to get the correct distance on the gauge, and then you have to use something else, either a mic or calipers, to take a measurement off of the distance from here to here, all right? So here's how that works. So you're just going to insert it into the cylinder, all right? And this takes a little bit of practice, all right? But what I'm going to do now is I'm going to go below the area, all right, where I've got that carbon buildup, and I'm just going to slowly tighten up the thumb screw, and I'm looking obviously for the tightest measurement on the gauge, all right, when it's parallel. And I'm going to slowly tighten that up, and you should feel a little bit of drag on your gauge when you're about ready to remove it, all right? So, now I've tightened the thumb screw, I get the gauge out, all right? Then I grab my calipers. Make sure your calipers are zeroed first, obviously. And then I take my measurement. So what I have got here is 4.114, all right? Now that may be off by 1,000th or two, all right? The snap gauge is not as precise as the dial bore gauge, at least not in my opinion, all right? But remember, what we're looking here is the bore is 4.110 is standard bore. And on the thrust side, and that's the measurement that I got, on the thrust side, you're going to have a little bit more wear. So it is possible that that cylinder is actually right at 4.114, okay? So that's how you use your snap gauge to take a measurement. Pretty simple. All right, so what we've got here is a dial bore gauge. Let's go ahead and set this up. It's pretty simple. The first thing you want to do is take your dial indicator and insert it, all right? And you want to insert it until you get some movement on your dial, all right? Okay, how about that right there, okay? And then go ahead and tighten the thumb screw. Now the next thing we need to do is figure out what length we're measuring, all right? You're going to need to have a greater length than the distance that you're measuring. So we know we're working with a 4.110 bore, so we need a distance that's greater than that, all right? A length that's greater than that. So we start with a 4-inch anvil, all right? And then we're going to use the 1/10 washer and the 50,000th washer, all right? So we've got 4.150, all right? So we've got those two washers on the anvil, and we go ahead and insert the anvil here, and we're gonna screw down the collar. All right, now, so the largest distance this is going to measure is going to be 4.150, right? Or thereabouts. So the anvil is not spring-loaded, but this is on this end, all right? So I'm gonna, if you watch the dial, all right, as I push that, the dial moves, and that's how we're gonna get our measurement. So let's double check and see what we've got here. All right, on my calipers, I'm getting right at 4.153, all right? So that's close enough for government work, okay? So we just wanna make sure that we're in the right ballpark there, that we got the maximum distance. And now let's see how tight this will be, okay? So it compresses down to 4.077. And you want the range that you've got, all right? So we got 4.153, the max range, the minimum, 4.077. You want the distance that you're measuring to be right in the middle, and we are with 4.110, okay? So we've got the anvil, we've got the correct anvil, we got the correct washer, so that is set up correctly. The next thing we want to do is we want to go ahead and zero the dial bore gauge, all right? So let's see how I'm going to do this. I want to go ahead and rotate this 90 degrees so I can see this better. All right, so again, as you're pressing on this guy down here, all right, that's where you're going to get your measurement. What we want to do is have your dial indicator read 0 right at 4.110, and we can do that because the face of your gauge moves, right? Okay, so this takes a few minutes, all right? And it's easier if you have a micrometer, all right? And you put the micrometer, your mic, in a vise, all right? And then use that, because you just run out of hands. But we're going to do it just with what we got here with the calipers, and we're going to get there. It just takes a little bit more time if you do it this way, okay? Let me get this sitting in the right spot here. And again, what we're trying to do is we want to get the caliper at 4.110, and when we have our caliper 4.110, we want this to read 0. So what I'm going to do is I'm going to get the caliper to 4.110, and that generally takes a second, and then I'm going to lock it down. There it is, 4.110. I'm going to tighten the thumb screw here, and I've locked down the caliper at 4.110. Now I'm going to move over to the dial bore gauge, and I'm going to put the caliper locked in at 4.110 on the dial bore gauge, and then I'm going to move the face of the dial, all right, until it is at 0. And I think I'm going to go a little bit more. All right, so still at 4.110 on the caliper. It's tricky. Let's see. I think I need to move it a little bit that way. Oh man, I'm close. All right, I'm moving it just a hair. I was one off. And that is it. Okay, so now what we've got is we've got our dial bore indicator zeroed at 4.110, okay? And that'll become important as I walk you through how to do the measurements. All right, step one, go ahead and wipe down your cylinder bores, all right? You wanna make sure they're clean of any debris. You don't want to be measuring debris. You don't want to be measuring carbon. And you also don't want any of that debris getting on your dial bore gauge because it'll throw off your measurement. All right. So the first thing we're going to do is we're just going to measure the bore. As a reminder, the dial bore gauge is zeroed, right? And when it hits 0, that's when we have 4.110, all right? Now, the numbers to the left side of the 0 are greater, and the numbers to the right side are going to be lesser. And we may have parts in the bore that are smaller than 4.110. All right, so starting at the top, and again, you're looking for the smallest measurement here. All right, and so the smallest measurement we're getting here is 2 thousandths. All right, 2 thousandths larger than 4.110, okay? So that's 4.112, all right? Which we expect there's going to be some wear in this axis of the bore. You're going to get your oblong bore because the wear is going to happen on the thrust side, all right? So we've got major thrust and minor thrust here. Again, that's that axis, okay? So we've just measured the bore and gotten 4.112, all right? But now we have to measure 2 other things, all right? We have to measure taper, and then we have to measure out of round, all right? So, all right, now to keep going, all right, I'm going to take 3 measurements, all right? So we've got 4.112 right here, all right at the top on the thrust. Then we're gonna go halfway down, and I've got 4.111, right? And down at the bottom, I've got 4.110, all right? Now I'm going to record those measurements. All right, that's number 6, thrust. So 4.112, 4.111, and 4.110. All right, what we've done is we've measured taper in this bore. All right, so I'm going to do a little public math here and see that we've got a difference of 2 thousandths top to bottom. All right, and our spec is 3 thousandths allowable top to bottom. So, and that's from the manual for this particular engine. So this is in spec as far as taper, all right? So you check the taper on the thrust measurement. All right. Now to check out of round, we need to check it against the non-thrust. And let's go ahead and do that now. Okay, so on the non-thrust, all right, now we're parallel to the center line of the crankshaft. All right, I'm starting off with 4.110, and then, wow, all right, I am 4.109. I am 1/1000th tighter in the middle of the bore, and down at the bottom of the bore, 4.110, okay? So again, at the top, 4.110, at the middle, 4.109, and at the bottom, 4.110. All right, now for our results here. All right, still working on cylinder number 6. So when we're measuring whether it's out of round or not, we're comparing these two measurements, all right? And these measurements have to be within 2/1000ths of each other. So this is 2/1000ths, right? And this is 2/1000ths as well, and that is dead on. So we are within spec on this particular cylinder for the specs for this particular engine as far as it being out of round. And now we've got to do that 7 more times for all of them. Again, you're measuring the taper on the thrust side, all right? And then you're going to measure the out of round against each other, all right? In that same length down the bore, all right? So that's top, that's middle, and that's bottom. On this engine, 3/1000ths is the max acceptable on the taper, and 2/1000ths is the max acceptable for out of round. So far, so good. All right, let's talk about the results, and I've got good news. All right, so what I've got here, these are the cylinder numbers, okay? And this is the thrust side and the non-thrust side, and that's the top, the middle, and the bottom, all right? And so, you know, for example, going here to the number 1 thrust side, you notice a difference here, and this is 1/1000th of taper, all right? So that's within spec. All right, because taper, the max is 3/1000ths for this engine. All right, and the non-thrust side is where I wrote down the out of round. And so we're at 2 thou out of round, and that is right up on the spec. And I've got virtually every cylinder is 2 thou out of round, but none of them hit 3, so we're still within spec. So 2, 2, 2. I've got, let's see, I've just got one cylinder, I think, that is only 1 thou out of round. But the highest number I've got for taper is 2/1000ths. None of them hit 3/1000ths, all right? So, good news. We don't need to overbore the block, and we can proceed with the rebuild. All right, folks, that is it for this episode of Project Brutus on the Bulletproof Garage. I hope you found the episode helpful and informative. And if you did, please consider hitting the like button and subscribing to the channel. Now, in between episodes, you can always find me on social media. I'm on Instagram at the.bulletproof.garage and on Facebook at The Bulletproof Garage. And as always, folks, thanks for watching. I really appreciate it. And we'll see you next time on the Bulletproof Garage.